Our first rig is going to be very simple, a bouncy ball rig, hence the ball on the screen. So the first problem at hand is to figure out what features we want the rig to have, and that depends on how it's going to move. In this case, let's say that the ball is going to be used in a simple 2D cartoon, with no sense of 3D whatsoever. Immediately, that tells us some things about how the ball is going to move. The most obvious is that it isn't going to be moving in 3D. It will only be rotating on one axis, and it will only be moving up and down and left and right. No depth, no 3D rotations. Whew, and that will make our lives easier. But it's also a cartoon, and that means squash and stretch. So all of this means we need to develop a rig that makes it convenient to move, rotate, and squash and stretch the ball in 2D. The simplest way to do this is to simply use the ball object itself as the rig. So, let's try that. So the first thing we want to do then is lock one of the translation axes of the ball so that it can only move in 2 dimensions. To do this, we need to go to the N panel in the 3D view. You may need to press N to toggle it on. We also need to select the ball. Now we can find the ball's transform panel, and toggle it open if necessary by clicking on it. You can also find the same data organized a little bit differently in the object properties. I prefer to use the N panel most of the time, because it's more convenient. But the object properties panel is actually the official place to look at and modify an object's properties, so keep that in mind. Now we need to figure out which axis to lock. So let's rotate our view slightly and play with the translation axes to see which one we want to lock. Aha! We want to lock the y-axis, because in this case, that's the forward-backward axis, and we only want the ball to move from side to side and up and down, not forward and backward. To lock it, simply click the lock icon next to it to toggle it on. Also, let's zero it out. Left-click on the field, and type in 0. Notice now, when we grab the object, it doesn't move on the y-axis. However, we can still modify it by typing in values like we did earlier. So it's not strictly locked, but what it does is this prevents the animator from accidentally moving the ball on the y-axis in the 3D view. We're now going to do the same thing with rotation axes, but in this case, we're going to lock 2 of the axes, not just one. So let's figure out which axis we want to be free. Go to the front view, and simply rotate the ball. We can see in the transforms panel that we're rotating on the y-axis, which means that's the rotation axis that we want to be free. So let's lock the other 2. And now we can only rotate the ball on its y-axis in the 3D view. So now we have a ball that's limited to moving in 2D space. It can only translate and rotate in that 2D space, so that the animator doesn't have to worry about accidentally moving it in an unintended way. But we still need squash and stretch. Now we could put the onus for this on the animator. The animator could simply manually scale the ball on different axes like this. But we can make the animator's job a lot easier than that. Why not have the ball automatically squash and stretch when the animator scales it? To do this, we first want to choose an axis for that squashing and stretching to happen on. In this case, the z-axis seems like a good choice. And we want to lock the other 2 axes so that the animator only has to keep track of animating that one axis. Now when we scale the ball, it sort of looks like squash and stretch already. But we still need it to expand and contract on the other axes. And there are 2 different ways that we can do this. We can either use drivers, or we can use constraints. In this case, drivers would give us more control over exactly how the ball behaves, but constraints are a lot easier. To keep it simple, we're just going to use constraints for now. And happily, Blender has a volume preservation constraint that forces whatever object it's applied to preserve its volume when it scales. We can add a constraint to the ball in 2 ways. The first is to go to the constraints panel. Make sure the sphere is selected, and from here, we can click on the Add Constraint menu and add the maintain volume constraint. You'll notice that a new panel appears that represents the maintain volume constraint. In fact, any constraints on the currently selected object will show up here as a panel. And this is where you manage the constraints on an object. So, for example, you can delete any constraint on an object by clicking on the big X here. The other way you can add a constraint is with a hotkey in the 3D view. Make sure the sphere is selected, and press Ctrl-Shift-C. The constraints menu will pop up, and from here we can select the maintain volume constraints. And ta-da! It's been added, just like the other way. And we can also see it in the constraints panel. Adding it this way is no different in terms of the end result. Many constraints have parameters that you can tweak to make them behave in different ways. In this case, the maintain volume constraint has a parameter at the top labeled free, and that's the one that we care about. This tells the constraint which axis the user is going to be scaling, so that it knows to scale the other two axes automatically. In this case, the user is going to be scaling the z-axis, so let's select that. Now if we scale the ball, it squashes and stretches. Yes! So much easier for the animator.